Well, hey there everybody, welcome back to Old School Math. Today we're going to look at solving systems of equations by using matrices. This is the accumulating idea in this unit, putting a lot of stuff together, not only from the matrices unit, but also from our previous unit on systems of equations. By the end of this video, you will be able to use matrices to solve systems of equations. And we're not talking just a two-variable, two-equation system. We're talking systems as big as 3, 4, 5, 6, 10 variables and 10 equations. We can do all those quickly in a matrix. A matrix can be very useful in solving systems of equations, especially for systems with more than two variables. To do this, you'll need to first arrange each equation so that the variables are in the same order. We call this standard form, something where you might have ax plus by plus cz equals d. Or for a two-variable equation, ax plus by equals c. The more variables we have, we can just keep adding those to the end there, but we always want to keep the number with no variable with it on the far right side of the equation past the equal sign. If a variable is missing, just know that coefficient for that variable is going to be 0. Still keep it in the same place and keep all the x's together, all the y's together, all the z's together, and you'll have great success doing this here. The whole idea is we're going to be able to take these equations and create a matrix where all of the coefficients are going to be elements of our matrix. The number of equations is going to determine the number of rows in your matrix, and your matrix is always going to have one more column at the end that is just the numbers past the equal sign. A quick example here, a system with 3 variables will usually have 3 equations, so we'd have 3 rows and we'd have 4 different columns there. Now once you have your matrix written, you can use your calculator to quickly solve the system. In your calculator, you're going to go back to the matrix menu, you're going to edit a matrix, and then from there you're going to go back to the matrix menu and select the RREF from the math menu. Now there's an REF and there's an RREF, and we're going to talk a minute about the difference between the two, but know that you're going to get the RREF. Scroll down, it's going to be option B. Hit enter, it'll take you to the home screen. So your home screen will say RREF, open parenthesis. You're going to go back to the menu. You're going to select your matrix. And I'll put matrix A in here. So you're going to select matrix A, and this is what your home screen should say. RREF, parenthesis, matrix A. Close up your parentheses and hit enter. So your matrix, when you do that, will look something like an identity matrix, but you'll have a last column on there that'll have numbers that aren't just zeros and ones. But everything else should look exactly like an identity matrix. We're going to talk a little bit more about what that new matrix that we create with the RREF actually means and how it helps us to solve our system. We're going to do that in some examples together. So go ahead and grab your calculators and follow along. So on this first example, I've got it written out for you. What we're going to do is we're going to first create a matrix that looks a lot like our system, but we're just going to use all the coefficients from our x, y, and z variables in our matrix. This last column in the matrix is just going to be the numbers on the right side of the equal sign. Now when you're doing this, you want to make sure that your x's, your y's, and your z's are lined up before you begin. So let's go ahead and put this matrix in the calculator. Go to second matrix. I'm going to edit matrix A. And you can see that I've already done this. I've already put this matrix in the calculator. Take a minute and do that on your own. Then what we're going to do is we're going to get this matrix. And to get this matrix, we're going to use the RREF from the matrix menu. Now there is an REF, but we're not going to use it. We're going to go to the RREF, which stands for Reduced Row Echelon Form. We'll pull it up on the home screen. We'll snag matrix A. We'll close our parentheses and hit enter. And this is the matrix that we get in reduced row echelon form. So what this matrix tells us here, this 1, 0, 0, 0, 0, 1, 0, 2, 0, 0, 1, negative 2, we see an identity matrix here, and that's really helpful because each number in this matrix corresponds with the coefficient of of our variables. So our new equation here would just be 1x equals 0, 1y equals 2, and 1z equals negative 2. Well, the ones aren't really necessary, so we've actually already solved our system. X equals 0, y equals 2, and z equals negative 2. On this second system, it's going to work the exact same way. Let's go ahead and make a matrix to represent our system of equations, but we need to be a little bit careful because we see x, y, and z in the system, but this first equation only has x and y. That means the coefficient with z is 0. So let's go ahead and write our x, y, and z and the number above our matrix here. And let's put the coefficients in. So the first equation, coefficient with x is -1. The coefficient for y is -1. And there's no z, so we can put in a 0 as a placeholder there, and that equals -2. In the second equation, we've got 1x plus 1y plus 1z. Remember, if there's no number in front of the variable, it's just 1 equals -1. Last but not least, we've got -1x plus 5y minus 1z equals 7. We're going to go into our matrix menu. We'll edit matrix A, and it's a 3-row by 4-column matrix. So let's go ahead and edit this. -1, -1, 0, -2. Do this with me. 1, 1, 1, -1, -1, 5, -1, 7. We'll go back to the home screen. And again, we're going to go to Matrix, go to Math, scroll down until you find RREF, hit Enter. And then we're going to do Reduce Row Echelon Form for Matrix A, close your parentheses, and here's what it gives you. It's going to give you this matrix here, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, -3. So we've got our x, our y, and our z, and then the number. So this tells us that 1x is equal to 1. We've got 1y equals 1. And we've got 1z equals -3. So we've solved our system here using reduced row echelon form. And we now know that x equals 1, y equals 1, and z equals -3. And that's a really simple way to solve a complex system of equations using the calculator. Now this would also work for our 2-variable systems with 2 equations. So if you go back to our first unit that we did on systems of equations, you can put any of those in the graphing calculator, as long as you put them in the right order with x's plus y's is equal to your number. Again, I hope this video was helpful to you. I hope you learned something, and I hope that it cleared up how to solve really big systems in a short amount of time using matrices. If you still have questions, drop me a comment down below. I'll be happy to help you out with that. And as always, thanks for watching. And if you want to get information about the next unit that we're going to be going through, please subscribe.